All right. Hi guys on YouTube. Give me a second. Give me a second. Hi Amna, how are you? What is up? ठीक है. Hello Roa. Roa, how are you doing? I'm okay. Okay. So if people can stay longer, let me know. Like Mesam says he can't. Ramis can't, right? And I think Abdul Hanan said he can't. Mesam, Abdul Hanan, 3 people can't for now. So far it's 3 against 4. And oops, that's not it. Okay. So last time we were talking about carboxylic acids. Carboxylic acids. And aside from their weird molecular formula or how they look, we realized they just act as weak acids. Hi Arif. Okay. So I think let's do a count at 7 again. Let's do if you guys are feeling up for it, maybe we can do a longer class. And yeah, continue from there. But I want to do as many papers as we can without getting tired. I also should put my iPad on charge. Let's see if it survives. Yeah. Yeah. Okay. So we realized it's an acid because it can give the H plus ion and it undergoes any reaction an acid can, right? Now we're going to take a look at another reaction. So one such reaction we did with alcohols was that you could have an alcohol, right? And you've seen this with alcohols, but not under carboxylic acids, even though we did it on the same day. This, if oxidized, can turn into a carboxylic acid. Right? So it's oxidation because it's gaining oxygen, right? And it's also losing hydrogens if you think about it. So it's oxidizing. Can I ask you guys to state the reagent for this? And the condition? Do you guys know? Shrug if you don't know, or say if you know what the oxidizing agent is. What oxidizing agents do you guys know of? No one's saying anything. Is my video frozen? We don't know? Shall I tell you guys? No one's answering? Ramis, how about you? Hi Arisha, how are you? Hi Amna. What's up? No idea? What? Didn't we not discuss KMNO4 as the oxidizing agent? The question is, what can I use to oxidize an alcohol to a carboxylic acid? And the condition is that you heat it. I'm okay. I'm okay. Thank you for asking. Yes? What do you guys think? KMNO4? Did we not do this? KMNO4 is an oxidizing agent. Did we not talk about KMNO4 with alcohols? I'm pretty sure we did. We can turn it into, didn't we talk about this yesterday? I'm pretty confident we did. Massam doesn't remember? Massam does not remember? Fermentation? What is that? It's too tiny for me to see. Combustion is there? I guess not. I guess we didn't touch it. I guess we didn't. Okay, my bad. I guess we didn't do it. So an alcohol can be oxidized to a carboxylic acid. And now note, there's nothing in the reactants we're looking at. We're not trying to balance the equation. We just want to know that this alcohol can turn into this acid. And the number of carbons remain the same. So you start with methanol and it turns into methanoic acid. And this happens with the presence of KMNO4. KMNO4 we saw as a strong oxidizing agent, if you recall, redox. Also, KMNO4 undergoes a very distinct color change. It starts from being purple, it goes to colorless when it's reduced itself. And it's reduced because oxidizing agents themselves. Oh, that's gonna. Can you guys hear that? I don't think that's the end of it. Right? Okay, I'll try to be louder. Oh my god. Okay. Do you guys recall KMNO4 now? Does it ring a bell? The other thing we did with KMNO4 was potassium dichromate, which was K2Cr2O7. Do you guys recall this? Massam got disconnected. Massam, we're just saying an alcohol can be oxidized to an acid. How so? With the presence of KMNO4. Because it's an oxidizing agent. We did two oxidizing agents. We use KMNO4 to oxidize any alcohol, well, technically not any, to a carboxylic acid. And methanoic acid will turn into, methanol will turn into methanoic acid, right? So on and so forth. Does that make sense? So we're not looking at trying to balance the equation or anything. Yeah, more or less this. So they'll practically ask you what the conditions are. So you say, you'll use KMNO4 and you'll heat it and you can oxidize it. Does that make sense? So alcohols can be oxidized to carboxylic acids. And do you guys understand why this is oxidation? Not only is it gaining oxygens, it's also losing hydrogens. Because over here you have 2 less hydrogens and 1 more oxygen. So it's like a double whammy. Do you guys agree? Does that make sense? Say yes if you guys agree so I can move on. Or if you guys have a question, I can try answering that. Agreed? People get it? Very straightforward. Take it. One thing we didn't talk about is we did talk about a bit about ethanol. Now ethanol can also oxidize to, what would it oxidize to, Vesa? Ethanoic acid, if it oxidizes, C2H5 COOH. Okay, so this is ethanol on the left hand side, ethanol. On the right you have its oxidized version, ethanoic acid. Right? On the left, this is your drinking alcohol. Can I just call it wine for, this would be the main ingredient in wine or, your beverages. Now, if you allow it to ferment with excess oxygen, it doesn't like glucose, it doesn't turn into alcohol but ends up turning into ethanoic acid. Do you guys, and we eat it, we or drink it, I guess. Do you guys know what ethanoic acid is when it comes to food? It's vinegar. Yeah. No surprise it has the word wine in it, kind of distorted. Isn't that weird? I'm getting... Can't we just add oxidized oxygen? No, no, you can't. You need an oxidizing agent because, you know, if you know, like, that's an interesting question. You can't just add oxygen to it. Like, I think try asking that question again in a bit. Give some more thought on it. Boltman, try asking that question again. You can't just think about carbon. Can you just add oxygen to it? Well, you burn it, right? Yeah, it'll happen in the presence of oxygen. Okay. So, how you make vinegar at home? Have you guys heard of like vinegar? It's not just the most popular one is white vinegar, which comes in like the white one. But you can have vinegar for a lot of things. Like you call it apple cider and other ciders, and you know other fruits and vegetables have their own vinegars. So I think I'm not sure yet, but pickles are also close to this, or pickles is something else. But yeah, does that make sense? You can also have vinegar. So this is essentially, so vinegar is acidic. If you want to check out some acid reactions, you can play with vinegar. You can pick up vinegar and put baking soda in it. That produces a lot of carbon dioxide because baking soda has carbonate, sodium bicarbonate, right? And yep, I love pickles. Okay. Anyway, does this make sense? Straightforward. I think nothing else. Just we're talking about a bit about vinegar and wine. Planning. Oh my god. Spam, yes, if you guys get it. Okay, people get it. Nothing too much here, just knowing these things will give you a lot of understanding. Okay, now we're doing something strange. We will do a reaction of a carboxylic acid for the first time that has nothing to do with it being an acid. Carboxylic acid reaction that has nothing to do with it being an acid, right? Every reaction we saw so far, I guess technically not this one, but this is not a acid reaction. It's more of an alcohol turning into an acid reaction, right? For the first time, we'll look at a reaction in which it's something completely different. Okay. What's the name of what? Oh, this is driving me crazy. But oh well. Let's say you have ethanoic acid. And it can react with an alcohol. Which alcohol? Any alcohol. So let's get a nice color for an alcohol. Let's get it. Let's make it green. We'll take propanol. What is the name? Esterification. And we'll see why. Don't ask me questions that, you know, are kind of like a few sentences down the line. It's kind of unfair. I'm just joking. Okay. Now what happens here is I'm emphasizing to the point where, I guess, pretend I'm saying this 1,000 times, right? Because if the need arises, I will say it 1,000 times. This is a carboxylic acid reaction where it's not acting as an acid. What do I mean by that? All acid reactions have the H plus come out first from the carboxylic acid, then that reacts as an acid. Over here, it doesn't do that. This time around, what's going to happen is the OH is going to come out instead. And that reacts with an alcohol's H, hydrogen. Not just any hydrogen, the hydrogen attached right next to the oxygen. None of these oxygens come into play. And that makes sense because if any of these, sorry, I said oxygens, I meant hydrogen. If any of these hydrogens were taking part in the reaction, you know, like, what do you call it? An alkane could have taken part in this reaction, but it doesn't. Only an alcohol can, because this hydrogen is used. With me so far? I will write the chemical equation, but can I explain the structure, what's going on? Then we'll go to making the chemical equation for this. ठीक है. Does this make sense? Okay. So what happens is the O and the H come out and they join to form water. This OH comes out, this hydrogen comes out, and it forms H2O. All right? What's left behind if the water, if I take out the water from here, from the two, okay. I have these two things left. It's called esterification, Arisha. ठीक है. I have these two things left. This came from the acid, this came from the alcohol. Now notice they have open bonds. They're ready to react. Will they join together? Can they join together? I mean, why not, right? They do join together, in fact. And I pick it up and I bring it here. And this is what's formed. These two molecules kind of, so to speak, merge together, right? This is esterification, or another word for this is a condensation reaction, because water is produced. This is also known as a condensation reaction or esterification. ठीक है. Why is this called esterification? Is because this product is called an ester. Now this is one of those times where we're looking at a new organic compound that's none of the four. We'll see one or two more till we finish all of organic. So the O left would always join with the C. Yes, this is it. This particular combination is seen as a functional group for an ester. What is an ester? Ester probably sounds very unique to the alkanes and alkenes and alcohols and even carboxylic acids, but an ester is still an organic compound, right? Yeah, and this is an ester. Now, unlike, we don't really do too many chemical equations for esters. Esters are not too reactive. There's some uses for esters which practically no one cares about, right? They're just used. They're normally used for scents and flavoring because they smell nice. I think the one I've drawn is very close to a fruity flavor. It's strawberry or something close to that. ठीक है. But the only thing you need to know about an ester is when you look at one, you need to be able to identify it. The other thing is you need to be able to name it, which we'll do right now. And the third thing is it comes, once you understand esterification, how they join, it comes into polymerization later on, which is the next chapter, right? So unlike acids and all their properties and alcohols and all their properties which we did, and alkenes and lack of alkanes properties, over here we'll just look at an ester without studying any of its reactants. We'll just study how an ester is made, and we'll try our best to name esters. Does this make sense? Spam yes if you guys agree. I should have stayed at work today. I'm having a bad time. People get it? Not many people are saying yes. Are we not confident? Are we getting it? So Arisha, Arib, Hanan, Rida, Ramis, Rahim. You're absolutely right, Boltman. The name is correct. Okay, not many people are answering. So Arisha, are you confused? Can I ask other people? Ramis is confused. Ramis is kinda gets it. Ramis is getting it. I'm getting a lot of likes this time around this week. Everyone's taking Olau seriously now. Not confused? Okay, that's good. Okay, maybe it's very easy for people. And yeah, okay. So naming an ester. Naming an ester is very easy. You just got to remember a few things. Now, first I'll write down this part of the molecule was ethanoic acid. Ethanoic, I'll just write down ethanoic because that's the important part. And this was propanol. Propanol. So this is how you name an acid. It has two names put together. Something I'll, then something, oh wait, or know it. I think it's better if I say know it. Any ester will have this combination of a name. Something I'll and something know it. What comes in the I'll part? In the I'll part, the name of the alcohol comes, or part of the name of the alcohol comes in. And in the know it part, you guys can guess where this is going, the acid part comes in. So this particular compound is propyl, I want my color combination proper. It's going to be propyl, it doesn't look too nice. Propyl ethanoate. Absolutely. Something I'll, something know it. Alcohol, acid. Something I'll, something know it. Alcohol I'll, acid know it. Alcohol I'll, acid know it. Alcohol I'll, alkyl lacedanoate. Right? And that's it. That is it. People get confused or find this difficult because they can't remember where's what. It's important to remember it. Maybe it looks too simple, but if you remember it once with, no point of confusing this ever again, you'll never be confused. And it's a good idea to remember it because this is, you do this in chemistry, in A-levels as well. Mesam, what part how to name it? The name of any ester, an ester is a product of an acid and an alcohol reacting together. Is that agreed, Mesam? Any ester will be an alcohol and an acid reacting together. Agree or disagree? Or agree to disagree or disagree to agree? Agreed? Right? So that's what you use to name it. Because if you look at it, otherwise if you try to name it, it's really complicated. And you'll see some complicated looking esters. So it could get really complicated. So what they do is they say, okay, the name is going to be something I'll, then something know it in white, if I ignore this, right? And in the I'll part, you'll put the name of the alcohol like over here. So I put prop in here, propyl, because it's propanol. So I put propyl because that's what we want. So in the yl part, you'll always put the alcohol's name. And in the noate part, you'll always put the name of the acid. So it's ethanoic, so you put etha in there, or ethan in there. So you get propyl ethanoate for this. So lemons, we're not really calling an alcohol an aisle. Aisles could be something else as well. Though right now we're just, focusing on, we're trying to focus on, like, the alcohol's name turns into an aisle and the noate comes from the acid. Take it. So this is straightforward. I hope you wrote this down because I'm going to move forward and I'm going to ask you to name this alcohol. Oh, name this ester. Let's see if we can figure it out. Let's get some interesting colors. I'm just purposefully trying to draw as confusing as a molecule as I can. And why does it undo my strokes? Can we try naming this as confusing as it looks? Now, you guys attempt it, then I'll tell you exactly how to academically approach this question. How would you try naming it? I'll give people half a minute to name it. That's more than enough time. Some people are saying it's called ethyl butanoate. Okay, people agreed. So the idea is people might get confused somehow, and this question might look really confusing if it's flipped the other way. Now this is what you need to do. Learn it as steps, right? You try to find the carbon that's bonded to the oxygen, the double bonded one. You identify that as 1. Then you try to look for the oxygen that's single bonded to that carbon with the double bonded oxygen. Over here. That's your 2. Once you identify that, drop everything. You've identified the bond where the alcohol and the acid met and joined, right? Does that make sense? This is where they joined. Agreed or disagreed? Agreed or disagreed? This is where they joined. Agreed? So you cut it up from here. You cut it up from here. You put a line. Now on the left hand side, this is my left hand side, this is my right hand side. Which is the alcohol and which is the acid? And what's the strong indicator that which is the acid, which is the alcohol? Because molecules could be flipped as well. Is my left part of the molecule the acid, or is my right part of the molecule the acid? And why do I know with confidence? How do I know? Which part will be the acid? I'm also asking, why do you think that's the acid? So you're right, left one's the acid, people are getting it. Has the carbon oxygen, so of course, this part of the molecule has the carbon oxygen double bond. It came from the acid. So this entire part of the molecule came from the acid, right? So this is it. So what is this right now? It has 4 carbons. So it had to be butanoic acid. This part was originally butanoic acid. Right? And on the right hand side, you're left with the alcohol because it has a single bonded O and no double bonds. And you try to name it, and you have ethanol, ethan right? And now you try to write the name for it. It's going to be ethyl butanoate. That's the name for this. There's a space after ethyl, right? I just put a space there, and there's no capitalization for the second word, even if you put the first word as capital, because maybe it's the start of the sentence. Does that make sense? Spam yes if you agreed. I think everyone got it, but maybe we can do one or two more examples to figure it out. Take it. Can we do the ulta though? Can we try drawing methyl propanoate? And let's try naming this particular one. Let's try drawing methyl propanoate, and let's try naming this. Nice. That's funny. Yeah, lemons got it. Ethyl butanoate. Even after passing O levels. Lemons, you've passed O levels 2 years ago. Why are you here? What's Groove Mirror? I don't know the song. PSL Anthem is a big meme. I missed it. It's really bad. Yeah. I'm doing alright, Abdullah. How are you? Okay. I'm going to draw methyl propanoate. Methyl is telling me it's methanol, and propanoate tells me it's propanoic acid. Propanoic acid. I'll try my best drawing it. I am in Pakistan. Yes, yes. Why would I? Yes, yes, we're asked to draw esters. Is the second propyl ethanoate? I don't know. It's very easy. Like, there's no challenge to it. Like, honestly. I think it's very easy. And it's kind of fun. Sing the national anthem. Why? I don't know. I sing what I want. Mm-hmm. Anyone recognize what I was kind of humming? I think I do the bad job at humming. But I don't think people would get it. Okay, the name of the second molecule, I guess everyone got it, is going to be propyl ethanoate. Alright, right? Because I break this up from here and I realize that's my eth and that's my prop. And on the left is the alcohol part, on the right is the acid part. Then why don't you know groove mera? It's strange. No, I don't know. What's groove mera? I don't know. What's groove mera? What is that? I think we put that on in class. I think kids were asking. No, it wasn't groove mera. Is it by Adam someone or Asfar or something? It starts with an A. Is the singer an A? Like, I'm not up to date. Don't even listen to it. Okay, fine. That's enough evidence. Okay, is Esters more or less confident? Now what's going to happen is, I'll tell you what you'll see. I'll tell you what you'll see. I shall tell you what you see. I shall tell you what you see. What you'll see in the next chapter is something similar to this. Let's say you have an alcohol, and not just any alcohol. You will have a special kind of alcohol where, let's say it has function groups on both sides. Right? Now I'm telling you this because I want you guys to absorb this as much as you can, and next time while you do polymerization, maybe tomorrow or maybe the day after, you guys know where this is going, right? So let's say I have an alcohol and on the other side I have an acid with two functional groups. Okay, now this looks really scary, right? How many of you guys agree this is scary? Raima, I don't know what you're on, but can you stop? It does look kind of scary, but you get used to it. What you realize is you don't do anything aside from complicated, just esters. You just make esters with it, right? So will this molecule make an ester? Of course, why not? Can they make an ester over here? Yes, why not? And they do. So I'll copy everything from the alcohol aside from that, the hydrogen, and I'll copy everything from the acid aside from its OH, and this is how it makes an ester. Does that make sense? Can I also do one thing? Let me highlight these two with different colors. That's the alcohol part we don't want to care about, and this is the acid part we don't want to care about. In hindsight, I should have highlighted the bonds instead. Try ignoring the highlights, he said, not understanding what a highlight is. TK. I hope this is making sense to people. Right? Do you guys understand? We don't need to name this right now. Okay? Not happy with the spamming I'm getting. Okay, does this make sense? It's kind of making an ester. Right? But can it continue to form an ester? What if you have a compound That's, what if another, because it's in a, we just looked at two molecules. If we mix two alcohols and two acids together, there will be many alcohol molecules and many acid molecules. Even though this molecule is made, when another alcohol comes right next to it, what's going to happen? So right now it looks complicated, but if I try to zoom in over here, on the right hand side I have an alcohol's OH, and on the left hand side I have an acid's COOH. Okay. This is the acid part, this is the alcohol part. Now if you've understood the earlier part, how they kind of just join together, you know, over here they'll do the same thing. The OH goes away from the acid one more time and the H from the alcohol, and they join in again one more time. Okay, Amna, I'll try to repeat it. How about everyone else? Are they following? How many of you don't get it? Just send me the salute face without the salute. Masam kinda gets it. Okay, how many of you get it? Send me the salute. Yes, they would form H2O. Yeah, it's only confusing because it's a big molecule, but essentially we're doing the same thing, but we've realized we can do it over and over again if such a molecule takes place. We're just doing it over and over again, right? Masam's a comedian. Okay. If you understand how an alcohol can join together to make, with an acid to make an ester over here, what is an ester? I mean, it's just the alcohol and the acid just join together. We're not really trying to understand what an ester is right now, right? Or we won't really spend any time focusing on that. We're just focusing on how they join, and that's what we're doing. So here's another way they could join. If you could have an alcohol with two OHs on either side and an acid molecule with, you know, two acids on either side, they could kind of, you know, join a lot more than once. Does that make sense? What is this? Ari just gave up. And I'm like, I gave up. Okay. Now what's gonna happen, if I can, is when will this reaction stop, I ask you. A lot of people are just not taking part today. Jasneet asks a very beautiful question. I like his question. How do you differentiate between an ester and a carboxylic acid? What do you guys think? Let's answer his question first. How would you differentiate it? If I have two compounds, how would you identify one is an ester, one is a carboxylic acid? Let's say I have this compound, they'll have, I'll try to put the same number of hydrogens on it. Right, I'll try my best. This is one product, and let's say this is another organic compound. Which one is the acid? Which one is the ester, and why? Jasneet asks, then he answers, and I'm confused. Right, so Jasneet, what do you think? Is this first one is an acid because it has a carbon double bonded O, and on the other side of that same carbon there's an OH. This has to be there. You have to look for this. If this is there, it is an acid, or at least that part is an acid, right? And if the same thing is there almost identically without the hydrogen, and there's a carbon next to the oxygen instead of the hydrogen, that's an ester. So this is an acid, this is an ester. Yee, 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 ha. Okay, I shouldn't. You guys get it? Well, I just explained what an ester is. Jasneet, I hope you get it. I compared the two. Okay, let's come back here. When will this reaction stop? When will this reaction stop? When do you think this will stop? What's going to stop it from reacting right now? What's stopping this part of the molecule from reacting with another acid? What is stopping it from reacting the OH? That's hilarious. Hilarious. Well, nothing's stopping it because the first two reactions took place. Because so far I haven't told you the conditions, but if the first two reacted, the others will react as well. And what's stopping it is absolutely nothing. This molecule will eventually show up right next to it, right? And will these two again react? Right now on the left you have an alcohol, on the right you have an acid, right? And it's an acid because, you know, this thing. And it's an alcohol because, you know, this thing. It's just an OH, and on the other side you have a COOH, right? And what's going to stop it from reacting? Absolutely nothing. And this will react furthermore, making a bigger molecule. And if you're confused at this point, try not to be confused, even though it looks very scary. It's the alcohol, then the acid, then the alcohol, then the acid. Back to back, one after the other. That's what they're doing. Tuck, 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 tuck. Lego pieces. You think we were just trying to advertise Legos when we were referring to organic compounds as Lego pieces? Ayaz asks a very beautiful question. He's asking what are the conditions required for this reaction to take place? For esterification, let me go back for a bit. For esterification, the conditions are this is important. Conditions are concentrated sulfuric acid plus heat. Sometimes you'll see heat under reflux, but that's not necessary because we don't really care about the reflux right now. But that's more of a later thing. But in the marking scheme, sometimes you'll say heat under reflux or reflux, just a reflux in a bracket or something similar. If you say just heat, that's fine. Okay, let me move on back to what we were talking about. Okay, now my question is, when will this reaction stop? What if there's an alcohol and another alcohol after it? So right now I have an acid on one end, so what if these two meet? So molecules are flying together. Remember Brownian motion and whatnot, they're all flying together, like, you know, passing each other. So this acid comes by, it comes close to this. Can an acid react with another acid? What do you guys think? Yes or no? Will this react? It doesn't react, because if it did react, it would have already reacted with itself, right? It doesn't react because in the beaker, it's all of these molecules put together, right? And it goes away. If another acid molecule comes again, will it react again? No, it won't, because acids don't react with themselves, right? But if another alcohol comes again, you've already put concentrated sulfuric acid and you're heating it, will these two react? As soon as they come close, they start reacting. And the H from the alcohol and the OH from the acid go away and they'll bond again. There are no big properties of esters. Do we need to know this? Yes. So let me ask you one more time. When do you think this reaction stops? It keeps on going when you have hundreds or thousands or 10,000s of molecules joined together to form one long chain. So this chain is thousands of molecules long, and you have many of these chains in the same soup of esters. Why doesn't the alcohol react with H2SO4? Well, alcohols don't have any reactions with acids. Why doesn't the glass you put it in, why doesn't that react with an acid? Has anyone seen Breaking Bad? Has anyone seen Breaking Bad? You haven't seen Breaking Bad? Okay. So if anyone's seen it, you guys probably can check the scene there. They end up, the heroes, so to speak, kill this guy and they want to make the body disappear, right? So what this guy says, get up, he tells him exactly, get this thing and we'll dissolve it in acid. And the guy is a chemist. Okay, why am I teaching you guys about hiding bodies? But oh well. Anyway, so he tells him to get this plastic bucket or like a big container, like a plastic barrel, and he gets it, and the guy who's not a chemist thinks this would dissolve because the acid is so dangerous because it's just plastic what it's made of. And what he does is, instead of putting it there, he puts it in the bathtub, because he thinks the bathtub is going to be a lot easier, and he puts the acid there and throws the body in the bathtub. And the problem with that is the tars are ionic compounds and it's mostly carbonates, like calcium carbonate and whatnot, and all of that stuff got dissolved in the strong acid they used. And so they did it on the first floor and the entire thing fell, and there was like a huge mess, is an understatement. But that plastic thing is actually made of something close to these things which we see here. Not exactly this, but you can think of them as long chains of alkanes, which we'll study in a bit. And they don't react because, remember, alkanes are unreactive, right? Yeah, that's a good note to have. Anyway, you have to be above 18 to buy acids from the store. Let's just call it that. Oh well. ठीक है. Do you guys understand this? What's the fancy way of saying many? We've exceeded time. What's a fancy way of saying many? And when you say many in, I don't know, games or something, there's a fancy way of, you know, like, yeah, Miral gets it. So this is an ester which we studied, and at the bottom we have this long chain. I've only drawn a bit of it, but imagine this is like thousands of alcohols and acids long. There are many esters, right? It's many esters. The fancy way, so it's many ester. That would be its name, but we don't use many when we're trying to be all scientific about it. So instead of many, we use the word poly. And this is what a polyester is. Have you guys heard of polyesters? Whoa, you've seen this and used this. You're probably wearing it right now. What's a polyester? What's a polyester? Not earphones, what? Polyester is this cheap cloth, synthetic cloth you get. So clothes are made of polyester, your bags are made of polyester. If it's pure polyester, it's a very plasticky feeling cloth. Your school bags are generally polyesters. You're wearing, like, you know when they say It's 70% cotton. That's like polyester wires woven around, like in the center, and it's cotton woven around it. The polyester is much stronger, right? So yeah, right? So clothes with polyesters, there is only one ester. I will not do A2 revision, Sir Bilal might. You can ask him tomorrow, he'll be online. Does that make sense? So you've already seen this, and we'll look at it in the second chapter a lot. So we've kind of been introduced to the second chapter already, polymers, which we'll do, you guys should do on Thursday. Is that clear? But when I was teaching, honestly, my class, they got really confused with polymers. So that took way longer than it should have. And I'm giving you an introduction to polymers so you guys don't get confused. Even though there are many of the molecules, you don't care, aside from how they're attaching together, you don't care about it too much. And there are too many names thrown around. Right? Can we end it here? Can we start doing some past paper MCQs just to cement? Let's spend at least half an hour doing some MCQs. All right. Now, can I ask how many people are staying back for MCQs? Well, I was a great teacher, back at my class, and they got really confused. So I don't know. I think they just were too stressed with the exams, so the schools were ending, so they were paying not too much attention in class, and they had assignments due. So Massam is going. I'm thinking at least half an hour, unless I got. So I'll ask you guys to watch the videos, but we'll continue with doing past papers. And you guys can always watch it on YouTube. If you guys don't get it, I think Sir Bilal can continue tomorrow. Yeah? If you don't get a question, make sure you take a screenshot of it. You can share it with Sir Bilal. He'll have the questions. But yeah. Are you guys ready? Can I move on to some organic questions? I also want to open my... We're doing intro to organic. Let's start with carboxylic acid. Let's start with alcohols because that's fresh in our hands, if that's okay. I'll go to... That's a very beautiful question. Okay, let's try this question. Part D is missing. Sorry for that. Lol. Yes, bye-bye, Massam. Bye-bye, Abdul Rahman. Bye-bye, take care, guys. We'll do some MCQs probably for half an hour. And yeah. Yes. Please help me get past. I think we'll just disable chat now. I think we're just done. The class is not ending. We're doing some past papers. If you guys don't want to stick around, let me know. But if those who can, I'll continue with this and you guys can watch it later before tomorrow's class. Right? I'm just taking half an hour more. If that will be... Very likely you will have a class tomorrow. Sir Bilal said yes. But I'll confirm with him and he'll announce it tomorrow on noon and teaching circle. Okay, so the answer is very straightforward over here. This is an alcohol, this is an alcohol, this is an alcohol, right? This is not an alcohol. So C is the answer. You guys follow? C is the answer. These are all alcohols. Straightforward. Let's move on. Let's see what other we have. Look at this question. Question 6. Molecular formula. People are saying A. I'm just gonna go a little faster. So let's see. This looks correct to me. If someone has an issue, let me know. Manufactured from ethane and steam, that is also true for ethanol. Oxidized to ethanoic acid, it can be oxidized to ethanoic acid. Produced by fermentation of glucose, absolutely. Used as a fuel, yes, Brazil. Used as a solvent, whoa! Look at that, chaka. D, yeah. Yeah. ठीक है. Let's look at another question. Let's look at, I should go in order. Let's take a look at, what is this? Generally easy questions. Okay, let's try 11. When the alcohol molecular formula of C4H10O is oxidized, what is the molecular formula of the acid formed? I guess at just best we can draw it. Let's try 12 as well. What do you think is the answer for 12? Challenging question. Let's try 11. 11 looks interesting to me. Yeah, that's all right. What do you guys think? What's the answer for this? What is the molecular formula of the acid formed? So this is how I would do it if I didn't want to get it wrong absolutely. So this is the alcohol and this will turn into right, and I'll just fill it out. So that's 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. And 2 oxygens. C4H8O2. 8. C is the answer? Oh, C is the answer? That's a horrible one. Yeah. For 12, it's D. Yeah, 12 is D. Let's try this, 13. Guys, why are you spamming? What is it? When ethene reacts with steam to form alcohol, which type of reaction takes place? Addition, fermentation, polymerization, reduction. What do you guys think? What would you call this? Now, we also call it hydration. That's not present over here. Now, you can probably rule it out. Let's take a closer look at this. Can this be called addition? You have ethene C2H4 that reacts with H2O to form C2H5OH, right? That's the reaction. Multiple products join in to form one product, right? So technically you could call it this, can't you? But let's wait on it. Okay. Is this fermentation? No, not really. Fermentation was specifically glucose reacting, well, or like Arisha mentioned last time, bacteria is involved, right? Okay, so it can be fermentation. Is it polymerization? Well, nothing's polymerizing, and we saw polymerization, or one part of it, when it came to our polyester, right? Is it reduction? Well, it's gaining 2 hydrogens but also 1 oxygen, and that kind of negates oxidation or reduction, so it's not really oxidation or reduction, right? So reduction is gone, polymerization is gone, and fermentation is gone, but you're kind of confident that, hey, that's not a bad way of calling this reaction. No one calls it that because people prefer calling it hydration, but it's one of those examples which I didn't stop talking about. Combustion of carbon is also oxidation of carbon, right? And that's the idea. This is hydration, but is this addition as well? Yes, it is. So that's the answer. Does that make sense? Reduction is not reduction. If it was just hydrogen, then it would be reduction. Does that make sense? Yeah? Okay. Good. Okay, that's 13. Let's take a look at 14. 14 is so silly, you're gonna hit someone. Sir, why do you teach us so much? These questions are stupid. Why do you teach us so much? Why are you taking an extra class? Because these questions are so stupid. How many of you think the questions are so stupid we shouldn't be teaching this much? You have 2 teachers taking 5 hours of class a week. I don't think schools do that. Schools have at best 3 to 4 hours of classes a week. Abdul Ahad, thank you so much for your comment. Please leave a comment as well. So Sir Bilal can see it as well. It's mostly his efforts. We have these classes. You're welcome. Please also try sharing our videos so more people can share it, because I'm kind of down. We don't have too many views, like 200 views. That's shameful. For free content. The answer is C, Q only. Yeah, they changed the name. So this is actually propanol and this is actually methanol. C only, I'm not against that. Q is correct. Okay, let's look at more. Which compound is an alcohol? Let's try 18. Let's name all of these. Yeah, so Shamir, alcohol with dichromate, it's tricky. Now, if you've done A levels, like, are you an O level student or an A level student? Manganate is a good ingredient to use if you're trying to get an acid out. Shamir, first tell me if you're an O level student or an A level student. Shamir Shahid. A and B. A and B are alcohols. I have failed you. I have failed you. It's on. How do you have A and B? How do you? Kya yaar? This is an alcohol. It's a diol. Isn't there some soap called diol? Something diol, Lifebuoy diol, something, Dettol, I don't know. B only. This is not an alcohol. There is no H next to the O. It's not an ester either, by the way, if someone's confused. Is this an ester? That's not an ester either. This is not an ester. An ester would have this with a carbon right next to it. So this is your acid. These two are function groups we haven't studied. You don't even study this in O levels, you study this in A levels. You don't study this in A levels. So this is never, you'll never see this. This is going to be A levels. I could probably, do that. Can you hear the music when I write it like that? Yeah. Shamir, you're an A-level student. I don't want to answer your question because I think it might confuse people. But you use dichromate when you're trying to oxidize an alcohol to a carbonyl, and you can use KMnO4 to oxidize, because KMnO4 is a stronger oxidizing agent. It'll take your alcohol, shoot it directly to a carboxylic acid. But if you're trying to get an aldehyde or a ketone, you're probably better off using a potassium dichromate and then distilling it out. Okay. C is an ester. Let's try this. A liquid reacts with sodium carbonate, potassium hydroxide, and ethanol. The idea, I like the idea behind this because you've just done the chapter. It's so clear in your head. It's really obvious. But what is this compound? This is a carbonate. What reacts with carbonates? Acids do. What reacts with potassium hydroxide? What is this? What is this? It's a base. It's an alkali. What reacts with it? Acids do again. What reacts with this? Not acids, not nothing. Oh, carboxylic acids do. All right. So it has to be ethanoic acid. I think this is a more challenging question if you haven't just done organic chemistry. Does that make sense? Can we move on to acid questions? Let's try question number 2. These are acid questions, by the way. I didn't realize we had already moved to acids. I believe there's already a playlist. If not, yeah, I guess just go to our channel and just type in past paper. You'll see a lot of past papers. We've done like 3 past papers for, 3 videos, 4 videos on O-level past papers. I think there are a lot of past paper questions, especially after a chapter. We always do past papers for that. So not we, Sir Bilal does it. B, I'll take the hard way and try to figure it out. So the first one is C4, H1, 2, 3, 4, 5, 6, 7, 8, H8, O2. Then I have C3, O, and H6. So that cannot be further simplified, whereas this can, and this is going to be C2, H4, O, right? And this one is C2, H4, O. So 1 and 3. That's the answer already, but let's confirm with 4. It's going to be C2, H4, O2, which is CH2O. So 1 and 3. Does that make sense? Bye-bye, Miral. You're welcome. Should we end it here? There are only 3 people now. Or do you guys want to continue a bit and take it up to 7:30? We're probably close to ending the questions anyway. My students were saying the chemistry questions are so difficult and they confuse it. That's why they hate chemistry. And when I do these questions, like, I don't know, they're not the most difficult. I mean, come on, look at them. I guess we're not doing all the questions. Let's try number 11. I like number 11. Let's try number 11. Apologies for D being incomplete. Ahmed Shahir, how are you? Have we met? How are you doing, Ahmed? What's 1794259? Your phone number? Continue a bit. What's the answer for this? What's the answer for this? I just feel so exhausted right now. I'm tired. Are you guys really tired? Arisha, Amna, Rida? I'm really tired. I wanna sleep. I think we'll end it soon. But no one's answering. Amna, Arisha, Rida, you guys see? Yes, it's C. But you're not confident. C is the only acid here, and that's why it'll have a lower pH. Everything else is an ester. We never talked about it being acidic, right? This is incomplete, but there were H's here that got cut out. These are esters. Can we also try naming this? This is methyl methanoate. This is methyl methanoate. Oh, it's the same molecule again. See, when you name it, gives you a better idea if it's the same molecule. If I hadn't named it, I would have no idea, unless I actually actively looked. They're both methyl. Oh no, this is different. Sorry. This is ethyl. This is methyl ethanoate, right? Methyl ethanoate, ethanoate. This is methyl methanoate. They're not the same. Okay. This is methanol. Oh, methanoic acid. What's wrong with me? And this is ethyl ethanoate. Ethyl ethanoate. Yeah? Yes? Oh, I like this question. Let's end it here. This is our last question for the day. Sorry for this thing coming down here. What app am I using? I'm using GoodNotes to write. It's pretty cool. I like it. It's not a cheap app. It's pretty good. I like it. Oh, yawn. It's impolite to yawn. I can rest in summer vacations. This is part of the deal. This is part of the deal. C? I think it's C. Now look closely, kids. What's happening here is you have two acid functional groups, and this was oxidized. Alcohols are oxidized, so you need two. You need two of these, right? So it needs to have an OH here, and it needs to have an OH here. And the only thing giving you that is C. Reda? Do you get it? Do you get it? Does that make sense? Yeah? Yeah, absolutely, you're right. D also has it, but it has also more carbons. Do you have, how many carbons do you have? You have 2 carbons, right? Ah, yeah, right. See? Ah, yeah, yeah, see? Yeah. Okay, let's end it here. We shall end it here. And you guys will do a bit of petroleum tomorrow and crude oil and stuff and start with polymerization ASAP. Is that okay? Do you guys have any questions? I think we didn't do enough practice, but we can. I'll also share this worksheet and you guys can bring in questions. I think if we do some questions right now, we might not, we'll be behind in the syllabi. Bye-bye guys, take care. Bye YouTube, thank you for being almost a great crowd. We had our hiccups, but yeah. Thank you YouTube, bye-bye. Take care guys.